So here we're going to demonstrate a one sample z-test for mean in JASP, and this is to cater for question number 22. Okay, so question number 22 is to be done using either Excel or JASP or SPSS or Minitab, whatever software that you use it. Okay, Excel and JASP are readily available, more so than SPSS or Minitab. So, okay, but any statistical software you have. Okay, so the scenario says that researcher Paul claims that the average score of all fundamentals of statistics math 1-1 is equal to 70%. To test his claim, he surveyed a sample of 35 of the math 1-1 students, used a significance level of alpha is equal to 0.05 and JASP to help researcher Paul. Okay. To help Paul complete the z-test for mean via a p-value approach in JASP. The data is presented in the following table. Okay, so now with regards to week 9, weekly notes number 9, if you go to page 5, it indicates to you the steps to do a p-value using any statistical software, including JASP. Now you must start with a pair of hypotheses. That's the first step. With a z-test for mean, you must convert the worded hypothesis to symbolic form. Okay, so seeing that we have already made a presentation already, we can go higher up. That's where we did it using Excel. We can copy these two hypotheses, H1, HA. That's the advantage of presenting online, because you can copy and paste. The board never erased. 27 pages from the beginning of assignment C. All the information is there. So we need to modify this because he's saying that the mean is equal to 70%. That's what he's saying. And the alternative statement, if he's saying the mean is equal to 70%, then the alternative will be not equal. Okay, so that will be a two-tailed test, equal and not equal, because he said equal to. Okay, so once he said equal to, that's his claim. So the complement, the contrary to the equal, is not equal. Okay, so that brings us in a two-tailed test. So he's saying equal, the alternative is saying no, not equal to 70%. So let's see who is right. Now the second step now is to input the data into Excel or SPSS or JASP. Now we already have the data in Excel. Okay, we already have the data in Excel. We have already inputted it in Excel. There it is. Okay. And so what I can do, I can put it on a new spreadsheet, copy and paste. Okay, and save it as CSV, because for JASP to recognize the Excel spreadsheet, you must save your Excel spreadsheet as comma separated values, CSV. Here we have done it already, so I'm just going to save over it, just to illustrate to you that you must save your, and this will always come up, so you just click OK, that you must save your Excel spreadsheet as comma separated values, CSV, so that JASP can recognize it. Okay, now you go to JASP, and you go to Show Main Menu, Computer, Browse, and JASP will ask you where you want to go. But since we have done this already, here it is. Then I can go back in desktop, recent recordings, math 1-1, hypothesis test, and here it is. Click on it, click open, and here it is, score of A. and look at their score of A. Okay. So we have just imported the variable of score into JASP. So what we're going to do now is from Excel to JASP. So what we're going to do now, we're going to t-test, because JASP has t-test inbuilt as default. So you have the z-test and you have the t-test. They are very similar. The t-test is for when your sample is less than 30. Okay, so you use the t-test, but it's very similar to the z-test. All right, so we go to one sample, and look, we have z-test there. All right, and the test value, we're going to put the test value as, let's go back to the hypothesis. It said equal to 70%. So our test value is 70. Okay, and the variable is score. Right. And automatically, JASP has given us our z-test statistic and the student test statistics, the t-test and the z-test, give it to us. And the p-value will be p-value right there, because it says now in the steps, after you have inputted the data into the program, you process the data and produce the respective output, and then identify the p-value from the output. So the output that just given us, look, it is there, and the p-value for the z-test is 0.001. So we can just copy this, just click, toggle along here, copy, and paste in our Word document. Okay, we can paste in a text box to maneuver it. Right. So we have identified the p-value to be less than 0.001. Okay. Now, when we go back to our next step, it says compare this p-value to the significance level of 0.05, or the alpha of 0.05, because we chose 0.05. It's very common to use 0.05. You can use 0.01, 0.025, 0.1, etc., but it's very common to use 0.05. So we're going to compare a p-value of less than 0.001 to 0.05. And the decision says reject the null if the p-value is less than the significance level, and do not reject the null if the p-value is greater than the significance level. So now our p-value is less than 0.001, very small. So now, since we have made a one sample z-test using Excel, we can just copy these statements and word it in. So decision, since the p-value of less than 0.001, that's a p-value, look at right there, the z p-value, is less than the significance level alpha of 0.05, we reject the null hypothesis. What is the null hypothesis? This is the null hypothesis. It is saying that the mean is equal to 70%. So it appears that the mean is not equal to 70%. So conclusion, based on the data, the average score of all the fundamentals of stats math 1-to-1A students is not equal to 70%. So this hypothesis, this claim that the researcher made here, so the researcher said that the mean, in the claim that the mean is equal to 70%, it appears that the mean is not equal to 70% based on the data. And we can even prove for the proof that the mean is not equal to 70%, we can actually calculate the mean itself. So we can go to descriptives and put the variable there, score, and we want for the statistics, we can tick the mean. We don't want the maximum, we don't want the minimum, the standard deviation. So you see all the statistics that we studied, they are right here. The interquartile range, the mean, average deviation, okay? Standard error, median, mode, all these things can be calculated. Okay, sample size, missing values. Okay, so what we want is just the mean. And Luke Jaspers automatically calculated the mean. The mean, we got a sample mean of 84.857, which is close to 85, approximately 85. So just further proof that the mean is not equal to 70%, because look, we get in a mean of 85. And here JASP is even helping us to the conclusion, because it says for the student t-test and the z-test, the alternative hypothesis specifies that the mean is different from 70. Okay, so look, JASP is even helping us with the true conclusion. And that's what we concluded right there, that the mean is different from 70%. So here you have the z-test coupled with the t-test using JASP. Remember, we said the t-test is especially used when the sample size is less than 30, but they are basically very similar, one and the same, like brothers, you know, older brother, younger brother, if you want to put it that way. One sample t-test for mean using JASP.